Let's look at this limit. Y is tending to infinity. 1 plus x over y to the power of y. So what does this expression equal to? It has been known for quite a while that this is equal to e to the power of x. Alright, this limit, as y tends to infinity, the output of this expression tends to e to the power of x, when e is equal to 2.71828 etc. Now the special case of this limit where x is equal to 1, okay, and it's written this way: y tending to infinity of 1 plus 1 over y to the power of y. Okay, now this is obviously equal to e, and this was worked out by Euler, the famous mathematician. And the way he did it was using the binomial theorem. Okay, the binomial theorem deals with expressions of this kind: x plus y to the power of z. Okay, and the binomial theorem teaches you how to expand this kind of expressions. Okay, so Euler used this binomial theorem and a bit of his mathematical tricks in order to arrive at the conclusion that the limit of this expression above here, 1 plus 1 over y to the power of y, as you replace y with larger and larger numbers, okay, it comes to the sum of the reciprocals of all the factorials. Okay, so it's 1 over 0 factorial plus 1 over 1 factorial plus 1 over 2 factorial and so on infinitely, and that converges to 2.71828, which is known as E, Euler's number. Okay, so, and the generalization of this case is where you replace 1 with x and say that in general it's the limit is equal to e to the power of x. But now we are going to try to arrive at that conclusion. We are going to try to prove it, okay, by taking this particular limit down below. 1 plus 1 over y to the power of y, the limit of it is e, as y tends to infinity. We are going to take that result as a given, and we are going to try to generalize it and say that replacing 1 with x will give you e to the power of x. Okay, so as I said, Euler used the binomial theorem to arrive at this conclusion. So we are now going to use that result and see how you can arrive at e to the power of x. So we'll write down the limit in question, that is y is tending to infinity, and 1 plus x over y to the power of y. Okay, so if you will notice this limit over here, 1 plus 1 over y to the power of y, it's 1 plus 1 over something to the power of the same something. So the limit that we are really interested in, we could try to rewrite it. Okay, so I could say that this is equal to 1 plus, now x over y, I am going to rewrite it as 1 over y over x. Okay, because y over x is a reciprocal of x over y, and 1 divided by the reciprocal is the particular number in which you are interested in. Okay, so I can rewrite this as 1 over y over x. So by doing this, I really have not changed anything, just I have changed the way it's been written, to the power of y. Okay, so half my work is done, because I wanted it in the format of 1 plus 1 over something to the power of the same something. So now I have it 1 plus 1 over something, but the exponent is not equal yet to the denominator, right? As you can see, it's not quite 1 plus 1 over something to the power of the same something. We can actually rewrite that as well. We can now say that as y tends to infinity, so 1 plus 1 over y over x. All right, and now the exponent is y, but I can actually rewrite that as y over x multiplied by x. Okay, because y over x multiplied by x is equal to y. Both the x's will cancel out. So once you have rewritten this, it in this way. So now you have to remember a rule of exponents, which says that x to the power of y times z, x to the power of y times z is the same thing as x to the power of y, the whole thing to the power of z. Okay, so when you have an expression like this, you can open the bracket and you can multiply the exponents together. So we could try to do something similar over here, okay, by saying that I'm going to rewrite it in this way. So now it will be 1 plus 1 over y over x, alright, to the power of y over x and x, and then the x I'll take it out of the bracket. Okay, so this is what we have written. So now if anyone tries to solve it or simplify it, so they will open the bracket and multiply the two exponents together and they will be left with y, and inside the bracket they can write 1 over y over x as x over y. But now take a look at this expression. It's exactly what we want. It's 1 plus 1 over something to the power of the same something. The value in the denominator is the same as the value in the exponent over here. Okay, so it's 1 plus 1 over something to the power of the same something. It's exactly what we are interested in, and we already know that it's equal to e, because e is the limit is the same thing. It's 1 plus 1 over y to the power of y. Okay, so 1 plus 1 over something to the power of something, as something tends to infinity. So just consider for a moment, if y is going to tend to infinity, okay, if y is tending to infinity, I'm writing it as equal to, but it's not really equal, it's tending towards infinity. If y is tending towards infinity, then surely y over x will also tend towards infinity, because no matter what the value of x is, as y tends to infinity, y over x will also tend to infinity. So you pretty much have it here. So it's 1 plus 1 over something that is tending to infinity to the power of the same something. So the takeaway here is that the value inside the big bracket, okay, is equal to e. So the value inside the big bracket is equal to e, which then means that it's raised to the power of x. So this is equal to e to the power of x, and that's it.